Hello to Dr. Chin. Today we are going to present the mini project of hypothesis testing. I am Ivan Giggs, number metric BS191102447, going to present the first introduction. What is hypothesis testing? Hypothesis testing is an act in statistics whereby an analysis and assumption regarding a population parameters. The methodology employed by the analysis depends on the nature of the data used and the reason for the analysis. Hypothesis testing also used to assess the plausibility of hypotheses by using sample data. Such data may come from larger population or from data generating process. The whole population will be used for both cases in the following description.
So my name is Ko Hwan, matrix number BS1911047. We'll be presenting the first question, the hypothesis testing for serum cholesterol, the not hypothesis being mu equals to 220 milligrams per cent against the alternative hypothesis, mu is not equal to 220 milligram per cent. So first we get the data sample, which is a set of 15 candidates chosen at random. We use the random number table to generate the numbers for the ID for the sample data. So from the table, we take the sequence 10480150111. Then we convert it to two-digit numbers, which is 10, 48, 1, 15, 1, 11, and so on. The same numbers are eliminated. So in this case, 01 is cut. The corresponding ID number of the data bank is then taken as the candidate. After tabulation, we get this result. Then we calculate the data for the z-test using the formulas of mean, variance, and z-value, which are these on the screen right now. From the calculations, we get the mean as 210.2, the variance as 185.886, and the z-value as negative 2.784. Then we take the confidence level at 95%, meaning that alpha equals to 5%. From the hypothesis, this is a test of a two-tailed test. Hence, alpha divided by 2, or 0.05 divided by 2, which is 0.025. The corresponding z-value is 1.96 and negative 1.96. The critical regions being more than 1.96 and less than negative 1.96. So the test z-value is negative 2.784, which is less than negative 1.96. We then reject the null hypothesis as a conclusion. Hence, there is insufficient evidence to conclude that the serum cholesterol levels is 220 milligram per cent.
Okay, so my name is Yuki Bong Chunja. I'm going to present a hypothesis test for systolic pressure, which is null hypothesis, and mu equal to 120 mmHg, and the alternative hypothesis to mu is less than 120 mmHg. So we have the same procedures from A. After obtaining the sample, the data was tabulated like the table below. We then calculate the data from the z-test using the formula like this. Mean will be x equal to total x divided by n, and then the variance and the t values like the formula shown. From the calculation, we get that means is equal to 128.067, and variance will be s squared equal to 99.620, and the t-test value is t equal to 3.13. We then take the confidence level at 95%, meaning that alpha equal to 5%. From the hypothesis, this test is a one-tailed test, hence alpha remains 0.05 at the left hand side of the tail. The corresponding t-value is negative 1.761, and the critical region being less than minus 1.761. So the test t-value is 3.13, which is more than negative 1.761. So we do not reject the null hypothesis. Hence, there is enough evidence to conclude that the serum systolic pressure is not more than 120 mmHg.
Hi, my name is Malvin Michael, and my metric number is BS1911 0.0276. So for my part, I will present question C for sodium level. The null hypothesis for sodium level is mu is equal to 140 milliequivalents per liter. And the alternative hypothesis is mu not equal to 140 milliequivalents per liter. So in hypothesis testing, there are 5 steps. So step 1 is to set the hypothesis and identify the claim. So null hypothesis is equal to 140 and alternative hypothesis is more than 140. So based on the hypothesis, this is a right-tail test, right-tail t-test. Step 2 is to find the critical value. So we tabulated the sodium level data in a table. This table is represent the sodium level. So to step 2, which is to find the critical value, we knew that the alpha is equal to 0.05. So the degree of freedom is n minus 1, and the degree of freedom is equal to 14. So the critical value is 1.76 for alpha 0.05 and degree of freedom is equal to 14, which can be seen in the graph below. T is equal to 1.761. So step 3 is to find the test value. So first thing first, we need to find the mean, standard deviation, and then we substitute to the z-test value. Then we get t is equal to negative 0.9.18. So step 4 and 5 is to make decision and to summarize the result. The t-test falls within the accepted region, which is negative infinity, less than t, less than 1.761. With the 90% level of confidence, the null hypothesis is failed to reject. So the average sodium level of 15 individuals is less than or equal to the average sodium level, which is 140 millimeter of mercury. Therefore, we can conclude that the average systolic pressure is 15 individuals, which is not more than 140 millimeters of mercury, which can be seen at the graph below. That's all for my presentation. We're moving to the next presenter. Thank you.
Arneta Iwol, BS191-10121. I'll present part B, Z-test for comparing proportions. The question from the data bank, select random sample at least 30 men and 30 women. Compare the proportion of men who are smokers with the proportion of women who are smokers by using the Z-test. Use alpha equal to 0.05. The null hypothesis is p hat 1 equal to p hat 2. Alternate hypothesis HA is p hat 1 not equal to p hat 2. This is called a two-tailed hypothesis test. Therefore, alpha divided by 2, we get 0.025. The critical values are negative 1.96 and 1.96. Figure B1 show the hypothesis test graph. Okay, these IDs were randomly chosen from a set of numbers from the random number tables starting from 0, 1, 0, 1, 1, and so on. Smokers are identified as those who have smoking status 1 and 2. The proportion of smokers to non-smoker of men is 0.6, and the proportion of smoker to non-smoker of women is 0.5. We calculate the overall proportion using these equations, and then we get p hat equal to 0.55. And the z-test for two proportions, we use this formula, and then we get z equal to 0.778. We know that the z-test falls within the accepted region. The null hypothesis is failed to reject, which is the proportion of men who smokes is equal to the proportion of women who smokes. Therefore, we conclude that the average amount of men and women who smokes are the same. Thank you. That's all from me.
Okay, my name is Edmund Egilit. My matrix number is BS19110201, and for my presentation of our presentation. So to conclude the whole hypothesis testing mini project, the conclusion is the truth behind a hypothesis depends on the statistical analysis. Aside of that, we need a sufficient amount of evidence in order to prove such hypothesis. The best way to decide whether a hypothesis is true or false is by involving the significance level of the test and a bit about the claim itself. And lastly, at the end of the day, hypothesis testing helps us to see what is true and what is false. Thank you for listening.